today we're going to take notes from lesson 1, or chapter 1, lesson 2. So I'm going to title it this way. So chapter 1, lesson 2. So you've opened up your spiral to 2 clean pages. You're on the even side, the right side, and that's where we take our notes. And today we're going to talk about the basics. So we're going to talk about powers and exponents. You need to add this to your table of contents. I need to update ours on the wall. And today's date, I keep wanting to write 9. 10/2/15. Okay. So we have some important vocab words that you need to understand when it comes to powers and exponents. So what I'm going to do is draw a picture, and then we'll label the pieces. Nope, stop. Okay. So I have a big 2 and I have a little 4. And the little 4 is high up on the 2. It's not the same size as the 2. It definitely is smaller. And it's up to the upper right-hand side. Okay. You guys familiar? You've seen that before? I'm getting crinkly eyes there from Michaela. Have you seen that before? Okay, you're scaring me a little bit. All right. So, this guy, together, the whole picture, that's called a power. So, it's a way to write a multiplication problem. But this isn't just any other ordinary multiplication problem. In other words, what does 2 to the 4th power actually mean? Okay, what does it actually mean? That's our big question. Let's see, Emily. So this is a very specific multiplication problem that has the same number being multiplied by itself. I stop after I have 4 of them because that's what the exponent tells me to stop at. Okay? So a power is a way to, let's say 2, to write a multiplication problem with the same factor being multiplied by itself. So the 2 together, the big 2 and the little 4, are called a power. Okay? So it's a way to write a multiplication problem with same factor being multiplied by itself, and I'm going to add the word repeatedly. Okay? Can anyone tell me what the 2 is called? He's got a specific name. Okay, and every time that we're doing vocab, I'm going to start highlighting because that means you better memorize this word because I'm going to be using it. It's going to be in your directions, and you got to know what it means. Okay? So nobody knows what the 2 is called? Base? I'm going to highlight him. Oops, sorry. Highlight. So the base is the number being multiplied repeatedly by itself. So that's our base number, is the number that's being multiplied repeatedly by itself. All right, hopefully you guys know this answer. What's the 2 called? No. I mean, sorry, what's the 4 called? Sorry. He's called the exponent. Now, somebody said power, and honestly, that some people do call the exponent of power as well. But we're going to use the word exponent, kind of distinguish the two. And that tells how many times to multiply the base by itself. So in this problem, it said, I want you to multiply 2 by itself 4 times. So I want to see 4 2's being multiplied to get to your answer. Okay? And last thing I'm going to write down here is how I read this. This would fall in the category of the base gets read first, 2, and then we say to the, and then whatever that number is, we're going to read it out. So that would be fourth. So we use what they call ordinal numbers. What order do they come in? Fourth power. Some people just say 2 to the 4th, and they don't use the word power, but again, that's what that's saying. Okay. Now, we do have 2 special exponents that don't follow this procedure. They have their own unique names. Does anyone know what powers we're talking about? We've already actually studied them. What are the 2 exponents that do not follow this 2 to the 4th power? They use that ordinal number. Okay, Savvy, I see you mouth in one of them. Okay, how do we read that? Yeah, so basically if we have an exponent of 2, we don't read that as x to the 2nd power. We read that as x squared. Square root, squared, okay, those values are the same. And then if we have x cubed is our 3rd power. And again, we read that as x cubed. Okay? All right, so what I'd like you guys to do is let's go over to the odd page and let's do some examples. And our directions are just going to say, for the first ones we're going to do is write each expression using exponents. You should be on the odd page with the examples. Write each expression using exponents. So we'll just do a couple of these. -2 times -2 times -2 times 3 times 3 times 3 times 3. So what I want, actually I'll put it underneath here. What I want to do is to write this without repeating myself. I only want to write each unique base once and then how many times that base shows up. Okay? So what are my 2 bases in this problem? -2 and 3. So I have a -2 times a 3. And the reason why I put parentheses around the -2 is because it's not just the 2 that's being raised to a power, it's the negative and the 2 that get raised to the power. So how many -2's were there?
3.
So I write that as my exponent. And then how many 3's were there?
4.
So my answer is -2 cubed times 3 to the 4th power. Okay? How about this one? A times B times B times A times B. Okay? What are the bases in this problem? B and A. But I'm going to put them always in algebra. We go alphabetically. So we have an A and we have a B. How many A's are there all together?
2.
2. It doesn't matter if they're side by side or split apart. We just count up how many there are of that particular base. Okay, how many B's? 3. So my answer is A squared times B cubed. Okay, so the order of them doesn't matter in terms of how they're listed. I get a lot of times somebody would write an answer to this on a test would be A times B squared times A times B. No, you're listing the same base more than once. List each base only once and then count up how many times it shows up. Dylan, gum needs to go in the garbage. Okay. All right. Now, the other set of directions that you're going to see, so I'm going to go to a new page for us. We're still on the odd, would be the directions change to evaluate. Okay. So if I have the quantity negative 2 cubed, or 2/3, excuse me, to the 4th power, what does evaluate tell me to do? Ethan E., what does it mean? 2/3. No, just tell me in words, not specifically for this problem, but in general, when you hear that word evaluate, what is it asking you to do? To solve it, come up with an answer, okay? So you can write yourself a little note. Find the answer. And I'm going to put in parentheses, value. And the reason why I want to put that in parentheses, right there in the word evaluate, is almost the word value spelled out completely. So that's kind of a hint. What are you supposed to do when it says that? Find the value. Find the answer. Okay. So we're going to do this in kind of bits and pieces. So this is basically negative 2/3 times negative 2/3 times, negative 2/3 times, that's a terrible times negative 2/3. That's how we start this problem. That's what to the 4th power tells us to do, is multiply negative 2/3 by itself. But because it's a fraction, we're going to split it into 2 little problems. What's negative 2 times negative 2 times negative 2 times negative 2 over what's 3 times 3 times 3 times 3. So first thing I want to do is get my sign and my answer. How many negatives did I have? 4 negatives. What sign do I get for my answer if I have 4 negatives? I'm going to get a positive answer. What kind of number is 4? Even. So anytime I have an even number of negatives, I'm going to get a positive answer. Okay? So I have an even number of negatives, I'm going to get a positive answer. So I'm not going to worry about signs because it's already in there. So now what's 2 times 2? So we've got 4 here. What's 4 times 2? 8. What's 8 times 2? And there's our answer for the top. Now we're going to multiply our 3's. What's 3 times 3? 9 times 3. And then 27 times 3. And that's where everybody goes, oh, okay. So let me show you a different way. You guys told me that 3 times 3 was 9. Well, what's 3 times 3? 9. What's 9 times 9? You have the right to do that. So your answer works out to be 16 over 81. So notice what we did when we were asked to evaluate. We first wrote the original problem, because remember, on your thirds work, sometimes we ask you what that original problem was. Then you write out what it means. The multiplication problem is negative 2/3 times negative 2/3 times negative 2/3 times negative 2/3. Then you solve. Okay? Let's do another one. What if I have 4 to the 4th power? Okay? What does 4 to the 4th power mean? 4 to the 4th power. What does that mean? Let's see. Sophie. D, sorry. Okay? Now, we have to figure out what 4 times 4 times 4 times 4 is. Well, what's 4 times 4? What's 4 times 4? From your chart, what's 16 squared? This is why you need to memorize your perfect squares, okay? This stuff should not be sitting there going, let me calculate it. Okay, what you got, Sven? 256. You gotta know those perfect squares. You've gotta know those perfect squares, okay? Now, one more thing that could show up is a different type of evaluate problem. I'm gonna go over to the next screen. It's still on the same page. This evaluate problem is going to involve variables. So directions are going to say evaluate each expression. If A equals 3 and B equals 5. Let's see, what are we on? What example are we? What number? 5? Is that right? 5? Okay, thank you. So we would have a squared plus b to the 4th. If they didn't tell me what the value of a was and what the value of b was, I'd be kind of stuck right now. Okay? So first thing I'm going to do is substitute 3 in for a. So I get 3 squared plus, and then I'm going to substitute in for b, 5. 5 to the 4th power. Then I'm going to describe what these mean. So 3 squared is 3 times 3. Now you should already know what that answer is. And 5 to the 4th means 5 times 5 times 5 times 5. Okay. Oh, sorry. I don't need that squared over there. What was I thinking? I already showed it what it meant. So I just have 3 times 3 plus 5 times 5 times 5 times 5. So we take care of the multiplication. And 3 squared is 9. And 5 times 5 times 5 times 5, well, let's break it down. 5 times 5 is 25. 5 times 5 is 25. You guys have seen this number show up before. That's your 625. Okay, and then we add them together, and that's going to give you 634. Okay? And that pretty much is all that we have for your notes.